Perfect. Thank you, Joe. Can you all see my screen?
Coming through here.
Perfect. So once again, welcome everyone. This is the last day of CrisisCon, or perhaps the first CrisisCon, given what Joe just said. Before we get into it, I want to mention a big thank to Joe for putting it all together. He's done a wonderful job. I don't know how many of you have been with us for the whole 5 days, how many of you are just joining us for today, but whichever way you look at it, it's been a wonderful job. So Joe, from myself and all the other participants, a big thank you. Now, without further ado, let's take a look at what I've prepared for you. Breaking Windows. We will discuss a couple of small unpatched vulnerabilities, which you probably don't know about. Specifically, we will talk about the fact that there even are unpatched known Windows vulnerabilities. And then we will take a look at what one might do with them should one choose to. The way I actually got onto this topic was a couple of months back. I got to thinking about how Windows deals with a couple of elementary strange conditions, and I found about 6 different weaknesses and vulnerabilities. In many cases, I wasn't the first to discover them, more about that later, but a couple of those will be in time probably patched by Microsoft and other vendors, more on that later as well. But what I wanted to mention, all of this I found without going too much into Windows internals, and all within 2 weeks. So perhaps to those of you who have never done any vulnerability research, this might be a good way to start should you feel the need to kill time during the next couple of days. What we will talk about won't be 0 days. Microsoft has been notified about all of these vulnerabilities and weaknesses. They know about them, but they have decided not to patch them. All of these are more fun than dangerous, i.e. you might use them for pulling pranks on your colleagues or coworkers, but some of them might be used in red teaming settings. So if you are a red teamer, perhaps something for you to think about. Who am I? You might read it on the slide. I lead an incident response team at ALEF. I'm also an incident handler with SANS Internet Storm Center, and I'm dealing with red stuff, blue stuff. I like it mostly purple. Now, let's get to the interesting part. I mentioned that there are unpatched Windows vulnerabilities. How is this possible? Before I get into it, what I'm going to talk about is in no way a criticism of Microsoft Security Response Center. These guys do a great work. The fact that there are unpatched Windows vulnerabilities doesn't reflect badly on them in any way. Microsoft just doesn't fix everything. If it's a small vulnerability or small weakness, they might leave it in if it would take too much effort to fix it. So Microsoft definitely doesn't leave large holes in Windows, especially not intentionally. That's not where I'm going. But if you've never reported a vulnerability to Microsoft Security Response Center or have never read their documents, you might be surprised how come that these things aren't always patched. So if we take a look at how Microsoft decides what they will and what they won't patch, it's all based on security servicing criteria, a document which you may find on the link which I've put there and on their bug bar. Now, what this says is that any vulnerability which is reported to Microsoft has to satisfy 2 conditions in order for it to be actually accepted as a security risk and be patched. You need to have something which breaks so-called security boundary, be it it's usable over the network, it can impact the kernel, it can impact other users, UAC, secure boot, you name it. And it also needs to satisfy a minimal bar for servicing. So it has to have a larger impact. Vulnerabilities with really small impact may therefore be left by themselves unpatched. What has low impact doesn't therefore always get fixed, and this is where we are going. If it's low impact, does it actually enable you to do something interesting? Well, in several cases, yes. We will, as I've mentioned, take a look mostly on vulnerabilities which you can use to pull pranks on someone, but some of them might be used for something more sinister as well. The first two have been known for a while now. I didn't know someone discovered them before me, but I'm not surprised, actually. And I wrote about them on Internet Storm Center. So far, I didn't publish the last one. I'm not sure if anyone has discovered it before, but it's actually quite funny. So we will take a look at that in a second. Let's take a look at the first one, how to discover contents of folders without needing any privileges in this area. So the question to you is, how do you discover a valid username, but not when it comes to Windows, but in web apps? If you've done ever some sort of web application penetration testing, you have probably come across the CWE 203, or information exposure through discrepancy. This is basically the type of vulnerability which says the application or the system gives us different responses whether we satisfy one or two conditions, i.e. when you put in valid username and invalid password, you get one response, and when you put invalid username in the application, you get another response. This way, you can determine whether a certain username exists or doesn't exist in a web application. A good example of this would be sign into Google, as you may see. You can actually, in this way, quite efficiently brute force usernames on Gmail. It won't help you much because you won't be able to log in, but you can definitely say, yes, this username exists, this username doesn't. The same thing can be actually done in Windows. If you make a user account, just a regular user account on a computer on which other users are as well, you can't obviously access their own folders because you don't have the rights to do it. But Windows does provide different replies if the file or folder you are trying to access exists and if it doesn't exist. And it does so whether you have the privilege to view them or not. What this means is if under these conditions we try to change directory to a non-existent folder, Windows will tell us that the folder does not exist. If we try to access a folder for which we don't have permissions, it will tell us, you can't do that, access is denied. But it will do so even if we try to do that for subfolders of folders for which we don't have any permissions, i.e., I know in this way that the file txt on desktop for admin does not exist, but the file secret.txt on desktop does. It's incredibly simple, but it works. It works quite well. Microsoft won't patch it for reasons we won't go into, but it's something which has been in Windows for a while and probably will be for a while yet. Is it useful in any way? Well, not really. It's quite easy to automate. If you have any brute forcer for web applications, it's just a question of changing a couple of lines, and you can probably use that for brute forcing or dictionary attacks against contents of folders which you can't access. On the other hand, it works only on local drives, i.e. in shared computer environments. You can't use it against remote shares. It's also rather slow. Brute forcing or dictionary attacks aren't the best and fastest approach to determining whether something exists or doesn't. So it's not too useful, or rather it's not too useful barring few fringe cases as you may see here. So to pull a prank on someone, perhaps for any deeper attacks, hardly. So let's now take a look at something a bit more useful. And that's how to rename file or folder without necessarily renaming the file or folder. All of this goes back to desktop.ini. You've all seen and interacted with these files. They are used in Windows mainly to change folder icons. You can do that by right-clicking on a folder, going to the Customize tab in Properties and just changing the icon. If we do this, what Windows will do is it will create a hidden system file called desktop.ini inside that folder. And it has a basic ini structure, just a header and a line saying which icon resource should be applied for that folder. In a similar way, you can use desktop.ini for optimization of a folder for pictures or video or documents, what have you. But what one might not expect from desktop.ini is that it's also quite a good way for renaming folders and files without actually having to touch them in any way. Or rather the files. You have to modify the folders a bit, as you will see now. So how do you rename folder? If you look at, for example, the documents folder on Windows 10 machine, inside it, there's a hidden system file, so you won't see it by default, but if you display system and hidden files, or if you just edit it, you will be able to access it. There's a desktop.ini with the following contents. There is shell class info, so the header. We also have a line which starts localized resource name and 3 lines which deal with icons. The icons we've already seen, so they're not that important for us, but the first line is quite interesting. What it says is operating system or file explorer, display this folder as having the name which is in system root, system 32, shell 32 DLL on some offset which is mentioned there. What we might do is change this line to something else. And if we change it to cool folder, what will Windows do? After a while, it takes a couple of seconds to a couple of minutes, or a reboot of the computer, or just restart a file explorer to become visible. It will actually rename the folder without renaming it. All right, but this is a system folder, documents. If we want to do it on any other folder, may we? Well, yes, there's nothing stopping us. The only thing which needs to be satisfied is that the folder in question has to have set the read-only parameter. Now, I don't mean you have to right-click it, go to properties and set it there, because it doesn't always work. Windows is sort of weird with folder and file attributes this way. But if you set it through a trip, for example, the command for setting attributes, it will work quite well. What might this give us? Well, the ability to rename any folder we want. It works even on shared folders in on shared spaces. So what one might do, if you have a remote file share, inside which is a folder which someone uses, but you don't have access privileges for it, nothing is stopping you from creating another folder which is named exactly the same way and hoping that the person will write to your folder instead of the correct one. You might at this point say, wait, Jan, you can't have 2 folders named the same way inside one subfolder or inside one path. Well, usually you would be right, but thanks to desktop.ini, you can do something quite amazing, i.e. rename all the folders which you see here, all the new folders and their copies, to basically a recreation of a famous movie scene, just with the help of a couple of desktop.inis, which is how I've come to this. So, it works on any folder for which we can set the attribute read-only, works on shell folders. Nice. But we don't have to necessarily end there. Files can be renamed as well with desktop.ini, and now we don't even have to set anything for the files. We still need the folder itself to be read-only, but besides that, we just have to create a desktop.ini file inside it. It doesn't have to be marked as a system file, it doesn't have to be hidden. An example of how that might be interesting or useful, if you have a shared folder inside which some important file resides, who says we can't copy inside the same folder our malicious file, for example? If we, next to that, create a desktop.ini with the following contents, we set localized file names for the files so that the important file is now called garbage and the malicious file is now called important. Windows will do that for us. This works only on File Explorer. Command line will not be affected. Neither will Total Commander, neither will any similar software. But since most regular users use File Explorer fairly exclusively to access any files or folders, this can result in some quite interesting and funny situations. Is it useful for any red teaming or any offensive activities? Well, partly. Requires permissions for changing folder attributes unless the folder in question is already marked read-only. On the other hand, you leave no logs of renaming or deleting any files or folders because you've basically just created a desktop.ini. So this might not be a bad way for certain red teaming situations. It's especially interesting because it works on shared folders as well as on local ones. So for any of you red teamers out there, if you need to hide any files inside a file share from users using the same network, this might be a way to go. This was more interesting than the first thing we've talked about, but definitely not the cool one. The cool one comes now. I was thinking to myself, what might we do with a link under Windows? There are many types of links in Windows. We know about symlinks, we know about LNKs or shell links, we know about URL shortcuts. There are a couple of other ones as well. And I got to thinking, what if we were to create a self-referential, infinitely self-referential link? There have been a couple of vulnerabilities related to this historically, not just in Windows. Those of you who remember the really early days of the internet might remember that there have been some problems with infinite redirects back in the day. There also have been problems with infinite redirects in Windows 7, if I'm not mistaken, specifically dealing with symlinks, which pointed to themselves, but you can't do that anymore. Or rather you can, but it won't result in anything bad. But perhaps with URL shortcuts and LNKs, it will. So let's take a look at the URL links. If you create a URL link, by the way, you can do that similar to creating a normal shortcut just by clicking new and shortcut and putting in, instead of the file path, putting in a URL. So in this case, I created a URL in this way, or URL file, pointing to the URL https untrustednetwork.net. Windows created for me this nice file. The file format for the URL files is mostly undocumented from what I've seen, but looking at it, it's a basic INI structure. You, as in desktop.ini, in this one, you can also add an icon if you'd like, but let's leave that aside for now. What do we have here? The first line, the really long one, is, from what I can tell, a class ID for URL link. Prop3 is additional mechanism for storing data pointing to specific types of links. We don't need either of these lines in order for the link to function. So let's leave them aside. Then we have the internet shortcut header. That's important. We have the ID list, which can be used for storing additional information. Again, it's not really well documented. And we have the URL. But what we really do need for a URL link or URL file to function within Windows are just these two lines. So if you take a text file and create just these two lines, you will have a functioning URL. Now, if we were to create a file called url.url inside the path C infinilink, and we were to put this target inside of it, what would happen? Well, nothing. We've just created a file inside a folder. What should happen? But if we were to click on it, Explorer crashes. And after a while, it's restarted. So nice, but is it useful in any way? Well, once again, it works on shared folders, so you might be able to do a URL bomb, for lack of a better term, in order to catch someone accessing that folder and clicking on the file which is named really secret stuff.url. But besides that, there's not much use. Perhaps you might use it as a productivity feature. It's sort of reminiscent of the old boss key in the old DOS games, which were able to change the screen to something other than the game you were playing. So in this case, you can fairly easily kill all the open windows. So yeah, besides that, just useful to pull a prank on someone. At this point, you might ask, well, Jan, is that it? Yeah, it's cool, but we were hoping for a bit more given what you said before. Well, it's not entirely all. I will show you a better way to use links. Specifically, shell links or LNKs. You know them all. They're used as the basic shortcut in Windows. If you do red teaming, blue teaming, you know them because they, apart from their legitimate use, they may be used and are quite often used as downloaders for other malware. You can just put inside the target call to PowerShell, which downloads other malware and then runs it, and you have fairly inexpensive and easy to make downloader. I've even seen actually a dropper created in LNK, which dropped Trigbot on the system which was targeted, which was quite interesting, but let's leave that aside. Shell links, besides being used for this nefarious purpose, are also or have been also the target of many exploits over the years. A couple of them are well known and patched now. Actually, if I remember correctly, I think even Metasploit has one exploit specifically targeting LNKs in older Windows, but the latest vulnerability associated with LNKs is actually from this February. It was a remote code execution, CVE 2020-0729. So if you are interested in LNKs, definitely check that out. But how is it possible that LNK's shortcuts, this really simple piece of file, can result in remote code execution? Answer is, well, they are not that simple. They're actually surprisingly complex. If we take a look at the documentation, which has 48 pages just for LNKs, we can see that they can have quite interesting internal structure. On the other hand, most sections which we see now are completely optional, so we don't need to use them necessarily. How can we create a link? We all know that just by clicking create a LNK, so new shortcut and pointing to something. So let's try to create a self-referential LNK. If we try to do this in Windows, so we have LNK and we try to make it point to itself, it won't go that well. It turns out that Windows rather doesn't like LNKs pointing to themselves, but documentation will save us. If we go through all of the 48 pages, actually we don't need to, we just need to go through, I think, the first 8 of them, we will find the link flags which determine how a shell link actually behaves. And we might find that the bit which is named X here is the one we want. So if we were to change the flags or the flag bytes inside the LNK file, we might be able to allow linking to another link. All right, it isn't what I would call straightforward, but it seems fairly doable. All we need is a hex editor and not to actually change different byte than we were intending to change. So let's try that. But actually, before we get into it, let's take a look at a special feature of LNKs in Windows, which is quite interesting. If you create a shell link, an LNK, which points to some file. In this instance, it points to calc. What happens when we access that folder? We don't need to click anything. An explorer will try to look whether the file the LNK is actually pointing to does exist or no. So it will try to access the target file. We'll get back to this in a second, because if we take our link and modify it to point to itself, i.e. we will change all the original targets to point to the file link.lnk, and we will also change the header in just the right bit, which is right the byte I'm pointing to now. We just need to add hex value 80 to it in order to set the allow linking to link byte. What will happen when we access the folder which houses or which holds the LNK? File Explorer will tell us it's working on it. It will last for a couple of seconds, and then the Explorer will once again crash, and it will start again. In this case, we've crashed the Explorer without having to do anything other than enter a folder, which is actually quite cool. It works on shared folders as well, so we don't necessarily have to do it locally. It can be a remotely mapped share inside which we've put an LNK, and someone's opened it, now their Explorer crashed. By the way, it works really well when placed on a desktop. It won't stop restarting the Explorer process, and you won't have any choice besides spawning a command line and deleting the desktop.ini manually if you ever want to get back to the desktop. By the way, this led me to an idea. It might not be a bad joke to program something which creates LNKs of this nature inside every folder on a computer. It would basically make it unusable, but it might be fun as well. So this might actually be useful. If you ever have an exploit which requires Explorer is restarted, which sometimes happens, this might be a way to go. This might be a way to do it in a fairly inexpensive way. Plus, if you place it somewhere and have a user navigate to it, now their Explorer has crashed, they will obviously think that something is wrong with their computer. So it might be useful for red teaming or similar situation when one might pose as an internal IT specialist, i.e. calling the user and saying, I see there's something wrong with your computer. Could you navigate to this folder? Oh, your Explorer just crashed. All right, now you need to download this and run it. You've seen that your computer isn't behaving correctly, so here is what you should do now. So this one is actually a bit cooler than the ones before. But that's all from me. What to take away from that? If you take a look at Windows, as we've seen, there are interesting, what I would call undocumented features in Windows, vulnerabilities about which Microsoft knows, and they won't patch them because it would either break something else, something much more important, or perhaps because it's too much of a hassle in some cases. In either way, whether you are a red teamer or a blue teamer, knowing about these might be interesting. None of these will get you anti-authority system. None of these will get you domain admin. None of these will allow you to escalate privileges. Well, perhaps some of them might in an obscure way, but basically it's something everyone can find. So if you are bored, especially now with COVID-19 around, you don't need to know anything about Windows internals to find weaknesses and vulnerabilities such as these ones. I intentionally picked these because these are vulnerabilities which anyone can find if you have a bit of technical know-how and the right mindset. So searching for these can be fun, and as fun is something which is sorely lacking for some people during these dark days. Guys, if you ever feel the need to have some fun, try breaking Windows. It's easier than it sounds. thank you very much for your attention. And since we do have, well, quite a lot of time actually, now it's time for Q&A. If you have any questions, please drop them to me and I will try to answer them.
Awesome, thank you. That was very interesting. It's always good to hear people talk about the sort of headline vulnerabilities or going after weak systems, but really looking at some of the lesser known items or whatever that might be minor in scope or seem like they're minor in scope, and being able to chain those together to try and do something really interesting with them even on systems that are otherwise fully patched. So there was, I'm not quite sure if I understand this as a question or whatever, from Sebastian Kaiser. I don't know if you're looking at the chat window, Jan, or if Sebastian, if you can clarify that just a little bit more.
I will kill the screen share and try to look at it.
Meanwhile, if there's anyone else, like I said, I'm still having issues with the Q&A panel, as there's some other people following along. So if you do have a question or something that you'd like to discuss further, just drop it in the chat window and we'll go from there.
So chat, Sebastian, are the special resource names still a thing that Explorer is getting blocked or crashed? I'm afraid I don't get that fully either. Sebastian, if you can elaborate on that, that would help. Question from Spencer. What was your thought process in first searching for this? Like, where did you get the idea? Honestly, I was thinking in terms of these are the places where I would look if I were trying to write Windows well. I would try to actually take a look at these areas and make sure that no one can, for example, chain link back on itself. I would make sure that no one can, through side channels, divulge the existence of files. Basically, since I have quite a background in web application testing, now looking back at it, I feel that that was something which also helped, because most of these vulnerabilities are quite similar to specific cases of web app vulnerabilities. So perhaps that mindset had helped as well. All right, I don't think we don't have anything more.
Okay.
Okay, so thank you everyone. Have a pleasant rest of CrisisCon, and Joe, once again, big thanks to you.